Right, I think I'm recording. Right, I just want to highlight the front page, which sounds like a weird place to start, but let's run with it. Right down at the bottom, there is a critical statement that's hidden. The second to last bullet point has got quality of extended responses will be assessed in questions marked with an asterisk. So instead of them stating, now what this means and the consequences of this are, any question where they say explain and it doesn't have an asterisk, that means you can break your points down into bullet points if you want to, because that can sometimes help when you're like trying to get, I've got 3 points to get over, let me just bullet point it. But, and I can't remember whether there was one on this paper, but obviously we'll get further and further down and do that. Yeah, I don't think there was on this paper, but at the top, what they will do is they will put a little asterisk next to the letter for the part of the question. And that means you have to write in sentences and there has to be structure to it. Okay? It isn't just a matter of getting your point over. So, you know, like when we're doing the open questions and we do that and discuss that in class, they're going to be the types of things where it says discuss this and it'll have just a tiny asterisk. If you put it in bullet points, they don't like it. All right, it has to have a flow to it. All right, so that's just something to bear in mind. Why they can't just say the quality of your written English will be assessed on this question. It's not like someone's had to like spend hours typing that, have they? So don't know, but just watch out for that. You had the same with the GCSE questions. Okay, right. Okay, so the first question was a little man computer question. This was universally awful, I found. Okay, most of you couldn't remember what translator translated assembly language into machine language. That's the assembler. Okay, a couple of you got it right, but that was all right. Right, the next bit was a really critical thing. It said the program doesn't work correctly. They've screwed up. They've switched their logic round was the problem. But it says describe what the program does. And it gave you some data. Basically, they're saying run through it. What does it output? A lot of people started describing the steps. That's not what they asked. They said, what does the program do? Not how does it work? If they said, how does it work? Then that would have been a great answer from a lot of you. But actually, they said, what does it do? So in this case, it compares the two inputted numbers and it outputs the smaller, which isn't what it's supposed to do, is it? Because it outputs, if you run through it and do a little dry run, that's what it does. It outputs the 4 because they've screwed up the logic a little bit. And then the fix to that was making the basic changes so that we output the value based on the comparison. Okay, so I'm not going to go through that. Quite a few of you got that right, and it was good. And there was a couple of things you had to really change to fix it properly. And they were fair on the mark scheme. They gave you a mark for each part of the fix. All right. So, but the takeout from that is that you've got to read the question. If it says describe what the program does, then you've got to say what is its outcome, what has it done, not how does it do it. I don't think they've ever asked on a little man computer thing how does it work, because how it works is there, isn't it? It's listed. They'll test you by saying with these input values what's produced. That's how they'll test you, to show that you understand how it works. Okay, right, and then this bit, there's pretty solid 4 marks for this. So this was the equivalent of half of the hardest programming question they'll give you on the paper. But it was like, right, okay, so this is actually quite straightforward. Some people overcomplicate it, and that seems to be a theme. You're adding things. You're doing too much. I've got the same problem with year 13. But it said here, write a procedural program that takes in 2 numbers and outputs the algorithm. It didn't ask if you're a function. All those people that started writing functions didn't ask for that, just wanted the code. Now, there is a standard way of doing this, and I've been pretty brutal when I marked it. If you're going to do input, that input needs to be stored. The standard way of doing that is how we would do it in most languages. We'd have a variable, and we'd just say equals input. Now, you could leave it just like that. That would be enough. You don't have to give an indication to the user. But that's always a nice element to do, isn't it? To just say, oh, yeah, you know what? Here's some description of what I want you to do. And just have a habit of that. So, enter number. And then on another line, that. You can't really write it. Some of you, I'll show you what some of you wrote. Enter another. Some of you wrote this. You did like input num. Which, yeah, okay, I can read it, but we've got to go and assume that the marker is going to be a bit loose, not necessarily very confident at marking these, and they're going to want to see standard stuff that's in the mark scheme, and that's how the mark scheme will be presented. The pseudocode is sort of Python code. All right, so please, and I've been brutal, and people did this. You've got to store input somewhere. It's got to go somewhere. Otherwise, what's the point in asking for the input? So do it in this format where you do an assignment to a variable. Okay, so please do that. And then the rest of it was pretty straightforward. And I think most people got this. Some people overcomplicated this. It asked to just output the higher item. Didn't say what to do if it's the same, but a lot of you did put extra work in. Don't bother. If your solution meets the letter of what they've asked, that's fine. No one's asking you to embroider. This is hard enough to do under pressure as it is, because you're like going, oh, have I got that up? Have I got that up? So I would just do that. And I would say, right, okay, so for me, I've done, if A is less than B, that means B is bigger. The key thing they're testing is that you can get your logic the right way round. So I'm going to print out B. Some people didn't print out the right thing. It just said print out the higher item. It didn't say give me an essay about which is higher. Some people did nicely formatted output. Didn't ask for that, did it? If it had said in a nicely formatted way, then yeah, you could have said this number is higher, and you could have printed the number out. That's all you needed to do. Okay? Doesn't matter if one of them's the same. If they're the same, then neither's higher. But it didn't say don't print anything out or print they're the same, did it? So just keep it simple. Okay? Quick 4 marks on that one. Right, the next one, a little bit worried about this. It shows a lack of going back over things. The program counter increments after every instruction in general, but there are some instructions that alter the program flow, and they're the branch instructions. That's what they were looking for. A branch instruction. They're the only ones. They're the ones that override. They say, don't do the next one in sequence, jump. So you've got BRA. So for that, you could have put BRA. I don't know which one was in there. Was it BRP? There was 2, weren't they? Yeah, BRP and BRA to do the loop, or to do a hop. So BRA and BRP was in there, but the other one that we know there is BRZ. So anything that affects the flow of the code is going to change the PC. Yep. I might not have ticked it on the paper, because I'm marking it on, putting it into my spreadsheet. I keep doing that. So it's like I go, what? And I forget to put a tick. I'll double check it though, Josh. Right, and then this next bit, this is just your standard fetch execute cycle. What register contents of the PC will be copied to in order to get the next instruction? It's the very first step of the fetch execute cycle. You've got to know this. PC to MAR. The MAR, remember, is responsible for selecting a memory location that we want to access. The start of the fetch execute cycle, the PC is telling us what memory location to access. If during the execution of an instruction we're using an addressing mode and we need to get more data from another address, that value will end up in the MAR. The MAR just is a selector. So that's the location we want to access. We want to do a read or a write. Okay. Right, moving on. Right, this was a car crash, this question. Terrible. And you don't get the benefit of the GCSE mode where they give you a mark for every nibble. So it's just one shot deals. Right, convert the binary number into hex. Whenever you get one of these questions, just put some markers. So you work from the least significant bit, identify 4 bits. I, as a matter of course, would just write that out again. So I can put it into the nibbles and I can see it better. I think it's a bit mean that they specifically format it so it makes it harder to read. And then they go and put loads of ones together, which your eyes go, you know, it's difficult to make a mistake. So always rewrite a number out for yourself. And then you just take the 2 nibbles, don't you? That's obviously F. And then that one's 6. But what you're not doing, ladies and gents, is you're not making your answer clear. If you've had to write, and you're always on binary questions, you're scribbling all over the bloody shop, I would super identify the answer. Okay. The next one, 2's complement, always a problem because you've got multiple steps and there's loads of scribbles that you write down. So we want to write down 19 as an 8-bit number, minus 19. So we don't know how to do that in 2's complement directly, so we're going to write down positive 19. Annotate what you're doing. You've got to do this. So I'm going to write down positive 19. It says it's an 8-bit number, which means we need 8 bits. So I'm going to put my sign bit in first. I'm writing positive 19. So my sign bit goes in first. Then I know I've got 7 bits left. I'm going to try and do it as a hero. I'm not going to put column headings down. All right. So the next column heading is 64. Can't have that. 32. So we've got 2 zeros. Next one's 16. So yeah, I can have one of those. Can't have an 8. Can't have a 4. But I can have a 2 and a 1. But that is not the answer, is it? That is plus. So I'm going to write plus 19. I'm just going to let the examiner know, look, I'm in process. Then I'm going to do the 2's complement phase, which, remember, the easy way of doing that is to just say, flip all the bits until you get to the last one and leave that as a 1. So in this case, I'm going to go flip, flip, flip. And you can write that, and some of you did. Some of you said flip. Okay, that's good. So I'm going to do flip, 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 flip. That's the last one, so I'll write that. Okay, and then I'm going to annotate that with minus 19. Yeah. Oh, yeah, that's my brain going mad. Yeah. And that's why it's important to double check. Because you can actually spot that dead easy when you look back at it. But as you're doing it mechanically, it's because I'm actually verbalizing. It always screws my head up. Because I start going like, what's the next thing I'm going to draw? I've forgotten about what I'm doing now. I'm an autopilot. But that annotation, and again, I'm going to underline my answer. I need to indicate. Some of you had, and I know somebody ended up, the answer was down here on the next bit of question. You can't do that. You can't do that. You're asking the examiner to ignore it. They won't hunt for the answer to a question. They are under time pressure, examiners. You've got to remember that. They don't get paid per hour. You say, take as long as you like. Take as long as you like. Go on, we'll keep paying you. Yeah, I'll go and watch someone else doing some marking for a bit. No, they get paid for the number of responses they mark, and they get a very short window of time to do it. Most of these people are still teaching, so they're doing a full day at work, and then they're going home and marking knackered. You've got to give yourself every best chance. All right. Right, the sign and mag. Sign and mag's nice and easy. We've already worked out the answer because it is positive 19 with a different sign bit, isn't it? That's it. It's great. That was so nice about these sort of back-to-back questions. So it's like, I've already worked out 19. Just want to make sure that the sign bit's 1. Always put your sign bit in first. And then I can write 19. And I'm going to leave a gap. Even though they're mean and don't, I'm going to leave a gap so that the examiner can mark it. I'm just going to say negative 19. And I might underline it. Maybe I should do that. Maybe I should tell you to underline it. And then not mark it if you don't underline the answer. That's what my O-level maths teacher did. If we didn't double underline with a ruler, she would not mark any of the work for a maths question. We thought she was the evilest biddy on the planet. But she was an amazing maths teacher. Everyone in the class got top marks in that class. We were top set math, but there was nobody who didn't get an A at O-level, which is equivalent to what you call A-level these days. Well, there you go. We did it in a year. But we hated her at the time. We thought she was just like mean and ridiculous. If we didn't put therefore, you know, sometimes on questions you put therefore on QED. If we didn't do that when it was, we put QED when it should have been therefore, she was vicious. She was vicious. Yeah, it's a pity we didn't have her for stats when we tried to do that in the year. The next year, we had a PE teacher, and that was like, nobody got more than a C. Funny that. Right, subtraction. Ooh, you've got to show your working. Now, most of you went and did it in deanery and then converted it. You're just throwing marks away. You can do it long subtraction, which is horrible in binary, because you end up carrying from miles away. You know, you have to go and get on a bus to get the carry. The best way is to do the two's complement and add, isn't it? So a few of you, and I don't like you writing numbers down to say you're converting it. You're just telling the examiner that you're cheating. You're not cheating. They just won't give you credit. You'll get a mark for the answer. That's it. But you won't get any working marks. 1 mark makes a difference. You could be 1 mark off a grade bound change. So it does matter. So do the flipping add. So rewrite. So we know we want to subtract this second one. So we need to do 2's complement on that. So I'm going to say, instead of A minus B, I'm just going to say that is equivalent to A plus minus B. That's what I'm doing. So I'm just saying that is my approach. I'm telling the examiner what I'm going to do. All right. So I'm going to take this number. I'm going to do 2's complement on it. So I'm going to go flip, flip. See if I can screw it up again. Flip, 1, 1. Right, that's the last one, so I'm going to leave it like that. Okay, so I'm going to add that to 1, 1. And again, I'm leaving that little bit of a gap between the nibbles because I want to make it as easy for me to do. That's the calculation I want to do. They want to see you working out. So they want to see the carry going on. So I'm going to go 1 and 0 is 1. 1 and 1 is 0, carry 1, 0, carry 1, 0, carry 1. That's a 1. That's a 0. That's a 1. That's a 0. Carry 1. Put that, some of you did, put that in there and label it as carry. Remember, the answer is 8 bits, not the 9 bits. Because actually, we've added 2 values, subtracted 1 value from the other. And I don't know whether that should be a negative number or a positive number or what. But the answer is what is in 8 bits. Okay. So I've added 2 negative numbers effectively here and ended up with a positive number. That just means we've had overflow. The number's too big. But the answer is that element. Okay. And label it. Answer. If you've got time, put the full word answer in case someone wonders what ants means. I'm not kidding, you know. Right. And then the floating point question. Wow. God, this was making me angry. My other half, who was also a teacher for 38 years, she could understand my pain when I was marking this question. Okay, because she taught computer science as well. Clarity, people. Got to explain what's going on. There were some people had moved the binary point and not put binary point. It was an imaginary binary point. Don't have an imaginary binary point. Some people had moved the binary point and you couldn't tell which direction it had gone because they'd drawn 2 binary points and then just put some squiggles in between, like this. So they've gone, which, to be fair, this is probably how it was generated. They probably had a binary point and they went, but basically that's what they left for the examiner. How do they know which way you went? What did I tell you to do? Arrow. They can't know. They didn't watch you write it. You're not giving them a video like I'm doing now of you doing the paper. That would be cool, wouldn't it? But you've got to annotate what you're doing. Some of you did it, and it was nice and clear, and the marks were easy to award. Right, so let's look at this. It says convert the denary number, a bit stupid a number, 1.625, but they at least give us the fraction, 5/8, to a normalized floating point binary number, using 5 bits for the mantissa, 3 bits for the exponent. Try to put them in that order. Do not put the exponent first. If they've got mantissa exponent, write your stuff down, mantissa exponent. Right, so with all these, same old story, put a fixed binary point. That's how we're going to write it. We want to write down 1.625. Let's do the positive bit. I need to make sure I've got enough columns so I can put a positive number down. Because whenever I'm writing a number down, I've got to put a sign bit in first. So I don't know how many I need. I'm just going to put a few. I've got 1. So I'm just going to put 3 down and go, right, okay, sign bit is 0. It's a positive number. Let's fill the 1 part in. So I'm doing the integer part first. Then I've got the binary point, and I've got to do 5/8. So let's put some, always put your column ends on when you're doing these fractional ones. Right, so I want 5/8. So that's a half and an eighth, isn't it? Yeah. What did I say was another way you could do that? Write them all down as eighths. Whatever your smallest one is, you go, right, 1/8. You could have written that as an eighth, which would be 2/8, 4/8. It makes it easy to add up then. So you change the numerator and keep the denominator all the same. Right, so that's my starting point. We've got to normalize it. Normalizing, remember, means that the sign bit should be followed by detail. So when we got a positive number, the sign bit is 0. DL is a 1. So we should go 0, 1. Or any other zeros that I've put on, they're just padding, aren't they? They're an extension to the sign bit. So I'm looking for the very last extension of that sign bit. So I'm going, yeah, that's just that one. That's where I'm going to. That's my sign bit. So I need to make sure I move the binary point that way. And I'm putting my arrow and I'm putting another binary point. So I've got a wonky smile now. But you got awarded a mark for showing that you've got to move the point. My next thing then is to write my mantissa out. I can write my mantissa. So I can say, right, it starts 0. Some of you skip the 0. So you effectively wrote down a negative number. You've got to keep that sign bit. Put your binary point in. That's for you for checking. So we got 1, 1. Now it said 5 bits, so I've got to be careful and stop when I've got 5. So that's my mantissa. Label it up. Give them a chance. Right, the exponent. We moved it 1 position. We need to know the sign. But we can look at this. We started with a number bigger than 1. When we normalize, we always end up with a number smaller than 1. So this needs to get bigger. So the exponent must be positive. It's only moved 1 position, so it's just positive 1. Now, it was what, 3 bits? I think even if you screwed up the question, most of you got the exponent, so you picked up a mark. Okay, but it's about clarity. You could actually say exponent 1 and write it in denary before you write it in the correct format. 3 marks. It doesn't take long to do. It's a couple of seconds job. 3 marks. You've got 3 minutes to get 3 marks. You banked time on this question. You lost a bit of time on that because that's going to take you 2 minutes. But the hexadecimal does not take a minute. That's like 10 seconds, and it's how long quick can you write? And that isn't. But you banked time on that one. Right, question 4. Oh, read the question. Read the question. First in, first out. You just got to know those, remember. First in, first out. That sounds like a Q to me. Okay. Stack is last in, first out. So that's definitely a Q. Right, and then this next bit. Wow, some people got this wrong, and I can't understand how. It's not even computer science. So, remember when you're doing stacks, whenever you push, you can just grow, can't you? So here, I'm going to go A and B. I don't think you have to worry about doing really lovely boxes. I think as long as it's nice and neat, clear and neat. So don't waste time like drawing boxes. Some of you did. And don't waste time doing that. You couldn't on yours, George, could you? Oh, you could have done because you did it on the paper, that one, didn't you? Right. Whenever I do a pop, rewrite the stack. So I'm going to do a pop. The top comes off. So I'm going to rewrite my stack. And I would actually do that to indicate to myself that that's come off. So my stack's in that state. Then I'm going to push. So I'm going to push a C on top. But then I'm going to pop again. So I'm going to rewrite. I'm going to pop. I'm going to rewrite my stack. So Z, Y, X, and A. And then I'm told to push. Clarity. It's all about being clear. Whenever we pop, redraw the stack. Okay. And then that'll eliminate the chance of screwing that up. Right. Okay. Next bit. 2 states. How the hell can we get to it? Right, so effectively, we've got to get rid of X and Y, and we've got to add an A. Well, how are we going to get rid of X and Y? Well, it's going to be popping, isn't it? It's the only thing we can do. It's not like we've got to run around the block and say, let's go X, and while I'm hiding behind a desk, let's get rid of the Y. No, it's just push and pop. That's all we can do. So all I'm going to do is pop to get rid of the 2 items, pop, and then I'm going to push an A. Now, one thing that I will say, and I wasn't picky about this, but in their example, they put like a function call, didn't they? And when they did the lettering, they did it as a string. So I would just follow their format and write it how they wrote it. Okay? But yeah, 3 marks. That was the same amount of marks as you got asked to do for the floating point. Ridiculous. Okay? In fact, the whole question was worth double the floating point question and probably took 1 minute, 2 minutes to do. Right, the next one. Ooh, right. They're asking us about queues. Same thing. It's just, can we follow queue processes? Now, this is a really good example of people didn't necessarily read the question. Some people did this, but some people missed some crucial stuff. They've marked the front and rear pointer. That's critical on a queue, remember? There can be things in the queue, but they're just not seen anymore because the queue's pointers have moved. So when you do this, you've got to make sure you update the pointers. Some people did this quite well and they like put an X next to the rear pointer. I saw that on a few people's. Right, so when we on queue, we add to the rear. So I'm going to on queue and I'm going to on queue the A and I'm going to move my rear pointer. Now, if you look how they've done this, I'm just going to put R. I'm not going to keep writing rear. Okay, they put it and it's marked at the end. So I'm just going to put mine in the same place. I've then got it on QB. Now I think this time you probably do have to draw the stupid rectangle, just so that you can keep that apart from it. Otherwise, it's all going to be blobbed. Then it says DQ. Now, just like on a stack, if you're going to DQ, I would probably redraw things. But with the Q, we can actually just say, well, actually, that just means move the front pointer to there, doesn't it? So I've moved it. It's now pointing at F. X has gone. So you might want to just say, right, well, that's come off, gone. Just indicate that. I then on Q, so I'm going to add the C. Move my pointer. So some people did this, and that's good. You're showing that it's moved each time. However you want to indicate that, it's up to you. Right, then it says DQ. So again, the front pointer's got to move. So that comes off. So I'm showing the process. And I'm moving the front pointer there. So my front is now pointing at Z. And then the last operation was on Q. So let's add another cell. I don't know why this is getting lower and lower, but it is. And they're getting fatter. And that's where my rear pointer ends up. So if you want to say, right, well, that was me working out. Let me just show the final state of the queue. You didn't need to, but you might want to. You might go Z and put front there, A, B, C, D with the rear pointer there. They specifically want you to show where the pointers are because they're moving. The stack was interesting because they didn't bother putting a stack pointer on that one. They just wanted the mechanics of it. This one a little bit more involved. Yes. Right, okay. I've got this on, this is videoing, so. Right, okay, so they actually give you a lot of space. You had space there to do some working out. I think I deleted the rest of the questions, so. Oh, this was a worry, this one. Right, draw a half adder using logic gates. Ideally, you should be able to do it out memory. Okay, but here is the truth table. Remember, there are two outputs when we add two bits together. The sum and the carry. So all you have to do was say, right, well, okay, I've got A and B. Let's draw that. Right, this one is easy. This is an and. Carry is and. So let's do the and first. Let's not muss about. Let's just say, in fact, I'm not going to do it like that. I'm going to do it this way. I'm going to draw my and up here. I'm going to do its output, and I'm going to label it carry. And I'm going to draw its inputs, which is A, and also B. So, I'm going to keep my diagram tidy. I'm going to have something like that, because I know B goes into another gate. Right, and then looking at the other one, I've got to work out what gate it is if I can't remember. So I'll look at it. It's all right. When they're both 1, I get a 0, which is weird. That's not or and. It's 2 inputs, so it can't be not. The only other one I know is XOR, but let's just confirm. So where they're different, we get an output of 1. That's XOR. So this is an XOR. Oh, the world's most hideous symbol to draw. So XOR is an OR with an extra bent, dinted line. So I'm going to do the dint first, and I'm going to try and mimic it to do the OR part. Well, that's not bad. I'm going to label it up as sum. And then I need to make sure that A goes in. So I'm just going to pull down, do the little join, and pull A in. That was it. Okay. So they could give you a bigger truth table without any sensible things, and you'd still have to try and draw it. So you've got to like follow the logic that's there. Right, Carnot map. Whoa, it's all over the shop. Right, the first thing is to identify. So let's do that. So I'm doing that. But this format of Carnot map does not help us. Okay, so I'm not going to do that first. I hate the way this does arrays. It's so rubbish. Right, they've gone and done this AB and then got 0, 0, 0, 1, 1, 1, 1, 0. That doesn't help us when we're trying to draw the logic. This is what I got stuck at when I did A-level. All those many years ago. Okay? nearly 40 years ago. Blimey. Right. If you get given this, because they've decided that students can't do Carnot maths from scratch, I don't know why, but they've decided that, label this up. A 0 means not. So that is going to be not A, not B. This next one is obviously not A and B. This one is AB. This one is A, not B. Now, this was a weird symmetrical Carnot map, so you could actually screw this up and still get the right answer. I'm going to do the same for the C and D. So it's not C, not D. Not CD. CD. C, not D. So that's my start point. That is the info I need to help me do this Carnot map. Then I do the circling. Biggest I can get. 4s are the biggest I can get. Then I say, right, what is that logic expression? So look at that and I go, right, okay, what stays the same? That's what I'm interested in. Anything that change is not valid, not required. So I look at this and I go across first. I go AB, then I've got A, not B. Ah, B's changed, so it must be A. Let's go vertical. We've got CD and then we've got C, not D. Ah, so it's C. But it's joined by an and. And you've got to remember what the symbol for and is. Some people didn't. And is the A. Yeah, I've said the wrong. Right, and is the A symbol. If you don't want to use, you don't have to remember, use the logic symbols. You can use the math symbol. So use dot. I'm doing B again. I'm going to get away with it. A dot C or A and C. Let's do the other one. So do your little arrow showing where you're drawing it. Again, going across, we've got not A, not B, not A, B. Well, so not A has stayed the same. So I'm going to have not A. I'll write it out in logic notation in a sec. Going vertically, I've got not C, not D, not CD. So D changed, so we don't care. So we end up with that. Right, in logic notation, so they're going to be A and C. That's going to be not A, which is why I don't like logic notation for this stuff, and not C. The math notation is a lot simpler. Then the final expression is going to be, and we haven't got a symbol, it doesn't say X or Q or anything, does it? So we just write out the expression. You join them with an OR. So in math notation, we should have got not A and not C, which is not the same as that. That's not in after you've anded. So don't do that. Or A dot C. So in logic notation, this is pretty minging. So we end up with not A and, some people put or, which is quite depressing, or, and I try and like drop the or a bit so it makes the, it just makes it stand out better for me. A and C. Right. Actually, the mark scheme let you just put the logic down. It said, draw the logic gates. Well, actually, they weren't very explicit here. That is the logic gates for the thing. But let's draw the circuit for this. Some of you attempted it. So we've only got two inputs, A and C. Notice how B and D aren't even relevant. So I'm just going to draw two inputs, A and B. A and C. My linear brain getting ahead of me again. A and C. So just do that. I need to AND twice and then or the final product. So I'm going to do the simple one first, this one. So I'm going to say, right, let's do an AND, the D shape. Awful. So A and C going into there. Okay, don't know where that's going. In fact, I don't like that. That's rubbish. do that a bit neater. I nearly did B again then. My brain's getting obsessed. Right, so that takes, and I'm going to tick that off. I've done that bit. Now I've got this bit. They've not, both inputs have got to be knotted before they're handed. So, one way of doing that, take a spur, put a knot. Take a spur, and I'm going to do my hand again. So I'm going to do an hand here. So that spur goes in there. I'm going to do another one coming down. Make sure it's clearly a dot on that line. Oh, hang on. Don't go down so far. You're allowed to do vertical knots if they make the diagram nice and clean. And they tend to make the diagram nice and clean. Okay, so that's the two inputs going in. These two outputs have got to be oared. So let's draw ourselves. Don't do a massive oar. Do a standard size oar. And then we just go, right, vertical, horizontal lines only, please. Nice and neat. That's the gates. Okay. You've just got to do some and get used to like ways of doing it. The vertical knot gates like that coming off spurs, they're quite nice. Some people did it just in line. That's fine. So you could have done it like that. You could have done A and C, knotted them like that, took them straight in to your hand gate, doing like that, and then tuck your spurs off behind. That's the other way. I think there's something nice about vertical knots. I don't know why. Probably because I'm weird. I just like them on diagrams. They look good. So yeah, you could have drawn it like that. It's up to you. It's your free choice. All those got marks. They did give marks for like the logic expression on the mark scheme. Don't guarantee that that's going to always try and draw the logic if it asks. Right. Whoa. Difference between a graph and a tree. we haven't done it, but there are some interesting answers though. Right, a tree has a root, and it goes to branches to ends. A graph, the major difference, a tree is actually a graph, ladies and gents, believe it or not. It's what we call a directed graph because you only go from the start to the leaves. All right, this is a direction to it. With a graph, you can have loops. So I could go on this little graph here, I could go A, B, E, I, F, D, B, E, I, F, and I could go around in a loop. Can't do that with a tree because they're one way. Graphs can be one way, directed or undirected. Okay. All the thing about the abstraction, that's about representing the puzzle, isn't it? There's no physical location. The graph's not showing any sort of thing like that, is it? Physicality. And graphs never show physicality. They just show the connections. And for this one, it was the moves, or what did they say? Intermediary stages. So they're just showing what stage follows onto what stage. That's all it shows, isn't it? So it's not showing what the stage is. Okay, there's no detail about each stage. It's just saying, right, so I can see from E that I can get to stage B or I, if that, whatever the rules of the game. I don't know what the rules are. It's just showing how the stages are linked. The next bit, this is probably the hardest thing that you can be asked to vaguely write about, visualization. I don't even like this on the spec. Visualization. Visualizations are for us, for humans. It's to represent data in a form that's easy for us to process. It is not for the computer. Computer doesn't need visualizations. The computer needs numbers. Visualizations are purely for humans. So always, if you're asked about visualizations, think, right, how is that helping a person? And that's how you should tackle it. Okay? Really weird question to get asked. Then it said demonstrate. They're never going to say demonstrate Dijkstra without using an essay. All right? You can write an essay, but it makes it ridiculously hard to meet the mark scheme requirements because the mark scheme is looking for specific detail. So for this question, we have got all those nodes. With Dijkstra, we're going to write all them nodes down. So I have got A, B, C, D, E, F, G, H, I, J. I'm going to write all the nodes down. So I'm going to say A, B, C, D, E, F, G, H, I. And then for Dijkstra, all I've got to manage is two things, cost and parent. Cost can change. Parent can change. So I need to leave a little bit of a gap. So I'm going to write cost there. And remember, that's cost of travel so far. And then I'm going to write a bit of a gap and put parent. So I'm not bodging it up. I want them to see any changes. That's critical. It told us where to start. Some people need to start at the start. Some people start at the bloody end. I don't know how you did that. It says the starting point of the game is represented by A. And then in the question it says, how would it find the shortest path to the solution? So we need to look to see what the solution is. Oh, the solution is represented by G. When you do that initial read of a question, one thing that I would do is annotate. So I would be highlighting that, and I would be highlighting that. We only need to know the start to build the data for the Dijkstra. The cost from the start is always 0. Everything else with Dijkstra, remember, infinity. We say infinite cost. That allows us to focus on the start item at the start of the process. Right, okay, so Dijkstra, quite a nice simple process. You look for the lowest cost that's still open. As you pick an item, you close it, so you don't pick it again. All right, we don't want to get involved in loops. We can put the parent as null. So you can put your dash or put null. Remember, we need that because that tells us when we trace the route back where we started. Right, so because everything else is infinite, I'm going to pick A. So I'm going to mark it off. And what I want to do to the examiner is I want to say the order I picked nodes. So I'm just going to write order, and I'm just going to put the numbers in like I showed you. So that was number 1. This also allows you a double check. So you can say, oh, hang on a minute, did I pick them in the right order? What I then do is I say, right, let's have a look at my neighbours. If they are open and available, have I got a cheaper cost to those neighbours? So let's have a look. So A has got a neighbour B. It's only got one neighbour. So that's going to be the first one we update. We say, right, okay, B's currently going to cost me an infinite amount of whatevers to get there. But from A, it's only going to cost me 5. So I'm going to say, right, well, that is going to be 5. The cost is 0 plus the distance we got to travel. And that is from A. I then go, and that's it. That's my cycle, isn't it? And I just keep doing this now. So I look for the next lowest open cost. So I pick B, because the rest are infinite. Close it. Number 2. Look at my neighbours. I've got 2 neighbours. D. Let's do that one first. So D cost me 9. It cost me 5 already to get to B. So a further 9. 9 and 5 is 14. So D is costing me now 14 from B. My other neighbour was C. That's going to cost me 8. So 8 plus 5 is 13. The numbers will always be close on these because they're trying to see how crap you are at adding up. I can't. The A-star one was worse, wasn't it? In fact, that was a disgusting question, I thought. The numbers were hilariously stupid. And they were like 1 out as well. There was like a 220 and a 221 or a 223 or something like that. So it's like, what? I can't even guess this. Right, so that was from B. No more neighbours. Well, there is. There's E. So you've got to make sure you check this. So E was 3. So 3 plus 5 is 8. So that one's actually quite cheap to get to. And that was from B. Right, there is one more neighbour, A, but that is closed, so we just ignore it. It's in the closed set. Right, we go round the loop again. I'm going to pick the cheapest, so it's going to be E. You've got to do this because the mark scheme is geared to you showing that you identify parents and costs, and that if you write an essay, you can get this detail in, but wow, you're going to bury it in a load of words. Right, so I'll pick E. And I look at neighbours. B's closed. So I don't need to do anything with B. So I've got a number next to it. So that's closed. But it has got a neighbour I, which is 4 away. So I go I and I go right. 8 plus 4 is 12. So that is I, and that was from E. If you forget which one you're putting down as a parent, it's the last number you picked. So I picked 3. That was my highest order. So E must be the parent I'm working with. All right, so let's double check there. Right, no other neighbours. So I'm going to go around the loop again, and I'm going to try and find the next cheapest node. So I'll look at these, and I can see I've got a 13, a 14, and a 12. Oh, I's going to get picked then, isn't it? So I'm going to pick I as my 4th pick. Look at my neighbours. I's got a few neighbours here. It's got F. F is still on infinite, so we can update that one. So it's going to cost me 3 to get to F. So 12 plus 3 is 15. So I'm currently on I, so I'm going to do that. What other neighbours have we got? G. G's on infinite, so we can update that one. So 6 to get to G. So 12 plus 6, that's 18. Double check you're adding up. Some people didn't add up properly. And that was from I. What other neighbours have we got? J. Oh, we got J there. Right, now this is an interesting one. Right, so it's 2 away from I. I wouldn't write J on there. No harm, no foul. It would be infinite. Right, so let's update that. So 2 from I. I'm having to scroll because I can't remember. So 12 plus 2 is 14. That was from I. You have not finished yet. You do not say you've reached the goal until you select it as the lowest cost. Right, so have I covered all the connections to I? So there was F, E, G, and J. E had gone. I've updated F, got I there. G has got I there. J has got I there. So I'm done. I think I've done. Right, I'm going to go around my loop again. I would love to pick J because then I can finish, but I can't because I've got a cheaper one up here, C. So I've got to pick it. It doesn't matter. The computer doesn't see the whole graph like we do. So we have to follow the process. Right, so looking at C. Where's C? Oh, there's C. C's got a neighbour B. Now I can remember that was close. That's gone. The other neighbour is G. G is still open. Let's have a look at the costings then. So, what am I on? I can't remember what number. Oh, C, the one that's got the biggest order. So C is 2 away from G. So let's have a look. 2 plus 13 is 15. G is 18. Whoa, we've got a better route. So I'm going to skip that one, and I'm going to say, what was it, 15. And that was from, and I can't remember which one I'm on, but looking at my highest order number, that's next to C. So that must have been C. Don't scribble out, just mark as ignored. And I'm working left to right. Be consistent, whatever you do. So I'm showing the update from left to right. They can work that out because that number's got smaller, which is the only time we update. C has got a neighbour B, but B's close, so we're done. Right, now, looking again at the open ones. It starts getting a bit more difficult because we've got gaps now. So we've got a 14, a 15, and a 15. We've got an infinite, so we're never going to pick that. We've got a 14. Now, we just picked the first one in the list. We don't know that J is the goal. So I'm going to pick this one as my 6th pick. Don't guess, just follow the process. So 6 was D. So looking at D, it's got a neighbour B, which is closed, and it's got a neighbour F. Right, it's going to cost me 2 to get to F. Was F open? F is still open, so it's going to cost me 2 to get to F. To get to D, it's cost me 14 already. 14 plus 2 is 16, so that ain't no better. So I'm not going to update that. Okay, finished my cycle. I'm now going to go back through, so I've got a 15 and a 15 and a 14. So I'm going to pick J. It's me goal, so I stop. Then I write the route out. Now you can say the cost is 14 because we know that, we've got it. All right. But I go in reverse. So I say, right, that is where I've got to. Where did I come from? And that's my parent. So I say I. I look at I and I say, right, where did I come from? So draw an arrow going to I. I came from E. Where did E come from? Look at E. That came from B. Where did B come from? So looking at B, that was A. Where did A come from? Nowhere. It was the Immaculate Conception. That's my route. Mark it. Write it. If you want to write the cost down, do. You've got the number. It says 14. The neatness that you do this and the clarity that you give to the examiner is gold dust. 7 marks for that. That's as much as the hardest pure programming question you'll get. Yes, it takes a little bit of time. It takes a lot more time when you're demoing it like I'm doing and I'm talking through it. But if you just neatly do it. Okay, right, next bit. The one with the most minging numbers on the planet. Right, the heuristic, estimation. Always say the word estimation. In this, you had to give a realistic idea of what this could be, what these numbers could represent. It isn't the number of toffee bars that are in the vending machine at each airport. Okay, it's got to be something practical. There was only really 2 answers. The obvious one is distance. You could have had the cost of the ticket though. Someone did put that. Who was that? Yeah, that was a good one, man. That was a bit left field, but it's a real valid one. Because it might be that you don't care about how far, it's just how much is it going to cost me to get between the cities. Or it could be, what else could it have been? Fuel consumption? Yeah. You've got to relate it to that as a standard cost. Don't like go too crazy. Okay? And a lot of people got the part 2 there. The purpose of the heuristic is to guide the algorithm, isn't it? To the optimal solution quicker. Okay? If it's a rubbish heuristic, it's not going to, but that's the purpose of it. That's why we have the heuristic. It's following Dijkstra, but it's saying, I know something about what nodes are closer to the goal. That's its purpose. Right, and then you had to demo it. 8 marks. I think they gave you 8 marks because they're horrible numbers. The nice thing about A star is you don't have to put all the nodes in. But we need to know where we start and end again. So it said the shortest distance between H and E. Right, so I'm going to do the same thing. I'm going to have my order. But this time I've got 3 costs to worry about. So I've got my nodes. But I've got, and don't put cost, put what they called. It's G, H, and F. So I'm going to write down G. H is my heuristic, and I can put all those in, and then I've got F. But I need to keep track of parent as well, remember. Don't make up your own names for these things. They've got proper names. Right, so let's just look at this graph. And when you're asked about these structures, you're just going to say graph. It's graph. You could say your undirected graph. You could say weighted graph, okay? But at the end of the day, it's a graph. But this is a weighted graph because it's got numbers on it, telling you the cost of travel. Right, so we've got, and they're not consecutive. They've done that on purpose to try and mess with your head. H, N, G, L, M. So I am going to write them all down. So I'm going to do H, I've forgotten it already. H, N, G. I've got space here, so I'm leaving gaps between. H, N, G, L, M, E. So L, M, oops, and then I haven't left a gap because I'm an idiot. Hey, oh, I've forgotten the letter now. L, M, E. All right. Right. The nice thing about A star is you can put the heuristic value in because it doesn't change on a static graph like this. So the estimate from H to E is 80. So I'm going to put that in. So I'm going to put that number in. N is 90. G 70. And remember, this is abstract again, so the numbers have got nothing to do with the lengths of the lines. L is 50. And remember, do this for your sanity. G plus H equals F. Right, M is 20. And then the goal, the heuristic to the goal is obviously always going to be 0. Because you're there. You're not going to travel anywhere. Right, okay. So we start with H. And we haven't travelled yet because it's the start. I'm not going to put any other costs in. So I've only actually got technically one item in my open set. So I'm going to select that first. So I'm going to select H. It has no parent. I've got to calculate G plus H. So my full cost is 80. I've now got to look at my neighbours. So I have to calculate the full cost first. Right, my neighbours for H are G. So let's do that one first. Right, G is 25 away. So it's cost me nothing. Remember, it's F that is your guide. F's your guide. Some of you made the mistake of adding F onto the cost, which made you end up with massive numbers really quick. It isn't. It's travel cost, G. It's how F's the estimate of how much it's cost you because it involves the heuristic. The heuristic is just crap, really. We don't care about it at the end. That is just a mechanism to help us pick. Right, so it cost me 0 to get to H. It's going to cost me a further 25 to get to G. So that's going to cost me 25. Calculate your F cost because that's the column we've got to look at. So 25 plus 70. This is when the numbers already start getting stupid. I think that's 95. Correct me when I screw this. And that was from the current one that we're looking at, which is H. Right, the other neighbour was, and this is where you start looking at this and you go, oh my God, these numbers. It's going to cost 210 to get to N. So that's travel cost to H is 0 plus 210. Ugh. 210. Add that on to 90. At least I can do that. 300. And that was from H. Right, so we've now got 2 nodes in the open set. We're looking at the F cost to decide which one to pick because that's the one that the heuristic is helping us with. The lower the heuristic, the less effect that has on the full cost. Right, so I'm looking at these two and I'm obviously going to pick G. So that's my second pick. So I'll look at G and I go neighbours of G. H, but that's gone. I've got L, 51 to get to L. And we go, right, it's cost me 25 to get to G. Add another 51, so that's 76. Where was I going? L. 76. Okay, do my calculation. So 76 now plus 50. We had 226. Yeah, 226. 126. Yeah. 100. Is it 126? Yeah. And that was from G. Right, what's my other neighbour from G? My other one is M. Oh, man. 176 from G. Right, G's cost me 25. 176 plus 25, 201? No, 201 because it's 176. Now I'm doing G to M. 176. So 176 plus 25 is, what did I say? 201. Right, add those two together so I get 221. That was from G. Right, no more neighbours. Let's go for the F column again. So the F cost, looking for in the open set, the lowest one. So I've got a 300, 126, 221. It's going to be 126. So I'm going to pick as my third pick L. L has got a neighbour G, but G's gone. So that's fine. It's got a neighbour E, which is a ridiculous 307 away. Blimey. So 307 plus 76. They couldn't have made these numbers worse. I hate 7s and 6s. So 307 plus 70 is 370. No, 377 plus 6, 383. Yeah, is that right? Where am I going? E. 383. It's only the G cost that you're adding up to the travel distance. The F column is for guiding who to pick next. Right, so that was 383 from, and I've forgotten what I was doing, it was L. So obviously there's no cost on the heuristic, so at least I can add that up quite easily. No other neighbours of L, so I'm going to go back around my loop. Looking for the cheapest, I've got a 300, a 221, and a 383. So I'm going to pick M as my fourth pick. Right, okay, so, oh God, 201. M has got neighbours, G. Please be gone. G's gone. But it's got a neighbour, N, which is 233 away. Right, so N is, what did I say? I've forgotten the number now. 233. It's cost me 201. So 201, it's only 210 to get to N already, so that's not going to be better. So I don't luckily have to do the adding up. All right, it's too big. It's not going to update. I've already got a cost to get to N. But I can get to E, 185. Right, so I'm at M. So 201 plus 185 is 385, 386. Is that a better cost? No. So I don't need to update. Yeah. Have I got any more neighbours of M? Not that I can see. Right. I've got to do my picks again. So I'm looking at F. I've got to pick N. I've got to pick N. Because it's 300. So that's fifth pick. Right. N has got a neighbour H, which is gone. It's closed. It's got a neighbour M, which is closed. So actually, it's got no neighbours that are open. So nothing to update. Then I can pick the final one. Okay. Have I done it right? That's the question. I've got to the end. So I say E from L, from G, and I think it was just H, I think. From H, H was the start. It wasn't a very long route. The numbers are horrendous. Okay, I might have done that wrong. I don't know. I've got to double check it. The numbers are horrible though. Huh? Not necessarily. It depends on what it is. Right. I may have done that wrong. I may have done it right. The numbers are horrendous. I did put a complaint into the exam board when that came up. I just thought it was ridiculous. No need to make the numbers that big and that horrible to add up. All right. I can't actually remember. I have actually got it in front of me. I think I have got a number wrong because I. What order did I do it? So HG. Ah, I must have got these numbers wrong. How did I get that? I picked them in a different order. I picked M first. Did I have that wrong? Hang on. So let's look at that again. L from G. So G was 25. No, that seems. L was 50, wasn't it? Yeah. 17126. M was 20. And it was 200, wasn't it, to get 10? No, I think I've done it right. I think I did it up wrong when I worked through it myself. Bit weird. Right. I'm going to stop the video there. It's all about clarity, people. It is just about clarity. There were some real bad attempts at all that. I'm going to stop that.